Very good morning to all of you. Today I want to start experiment 12th. Title of experiment number 12 is determination of residual chlorine of the given samples, whether it is water sample or sewage samples. How to determine residual chlorine? That is the today's topic. Course outcome is given based on this topic and as well as based on this subject. There are 4 course outcomes. One is acquire capability to conduct experiments and estimate the concentration of different parameters. Second course outcome is compare the result with standards and discuss based on the purpose of analysis. Third course outcome is determine type of treatment, degree of treatment for water and wastewater. Identify the parameter to be analyzed for the student project work in environmental stream. So these are the course outcome is prepared. Now title of subject is Environmental Engineering Laboratory. That subject code is 18CVL67. This comes in 6th semester of Civil Engineering Department. See, these are the apparatus as well as equipments are used for the experiment execution purpose. So in these apparatus, some apparatus are used for these experiments and some equipments also used to conduct these experiments. Okay, but all of you remember these apparatus and equipments are more helpful to execute environmental engineering laboratory experiments in the lab. So be carefully handle and be systematically use these apparatus for execution of your experiments. Okay, let us see concept of residual chlorines. The quantity of chlorine required for disinfecting certain water will be depend upon the quality and quantity of organic impurities and bacteria present in that water. The normal dosage of chlorine may vary between 0.3 to 1 milligram per liter. The dosage of chlorine also depends upon the period for which the chlorine remains in contact with water before being served to consumers. Okay, the dosage of chlorine also depends upon the period for which the chlorine remains in contact with water before being served to consumers. This period is called contact period. This period is called contact period. The amount of chlorine left in the disinfected water after the contact period is called as residual chlorine. The amount of chlorine left in the disinfected water after the contact period is called as residual chlorine. It is a general practice to add chlorine so that a residue of 0.2 to 0.3 milligram per liter of chlorine is left in water after the contact period. This residual chlorine takes care of the future recontamination of water in the distribution system. Okay, this residual chlorine takes care of the future recontamination of water in the distribution system. Which are the apparatus are required to execute these experiments? Let us see. Burettes, pipettes, measuring jar, beakers, conical flask, glass rods, spoons, weighing balance, dropper, etc. These apparatus are used to execute this experiment. Let us see which are the reagents are required to execute this experiment. Sodium thiosulfate of normality 0.025 N is used. How to prepare this sodium thiosulfate reagent? Dissolve 6.25 gram of sodium thiosulfate in 1000 ml of double distilled water, that is freshly boiled and cooled distilled water, and dilute it. Add about 5 ml chloroform as a preservative. So now it's become sodium thiosulfate of 0.025 normality. Potassium iodide reagent is required. Now how to prepare this potassium iodide? See here. Dissolve 5 gram Ki in 100 ml double distilled water and dilute it. So now it becomes potassium iodide reagent. Next is glacial acetic acid reagents. Now it is freshly available, ready-mades. Next, freshly prepared starch. So this also required for this experiments. So now how to prepare freshly prepared starch? Let us see the procedure. Dissolve 2 gram of LR grade soluble starch in distilled water and pour this emulsion into 100 ml of boiling water. Allow to boil for few minutes. Add 0.2 gram of salicylic acid or toluene as preservative. Cool this solution and then use. So this is the procedure to prepare starch, that is fresh starch. Okay. Next, after the preparation of reagents, so now you start the experiment how to execute. First step, weigh accurately 0.5 gram of fresh bleaching powder. Weigh accurately 0.5 gram of fresh bleaching powder and transfer to mortar. Add small quantity of water to prepare a fine paste. Add some more water, stir and allow to settle for few minutes. Decant the supernatant. Repeat it till fine suspension is obtained. So this is the first step of the samples how to prepare. Okay. Take 200 ml disinfected waters. Disinfected water means tap water plus bleaching powders. That is called disinfected waters. In a conical flask. Then add 2 ml glacial acetic acids followed by 2 ml potassium iodides in conical flask. You add. Then after addition of this glacial acetic acid and 2 ml potassium iodide, color of this solution changes to yellow if residual chlorine is present. When it becomes yellow, if residual chlorine is present. Add few drops of freshly prepared starch, then color changes to blue. After addition of freshly prepared starch, few drops, now color changes to blue. Now titrate against sodium thiosulfates till blue color disappears. Okay. Now titrate against sodium thiosulfate till blue color disappears. Then after disappears of blue color, now note down the volume of sodium thiosulfate consumed in mLs. Now same procedure you repeat up to 3 trials. Okay. Now write the observations and calculations. What are the observations and calculations? Now see the observations. In burette solution, in burette, which solution is filled? 0.025 normality sodium thiosulfate solution. In conical flask, 200 ml of sample, that is tap water plus bleaching powder, plus 2 ml of Ki solution, plus 2 ml of glacial acetic acid solution, plus 2 to 3 drop of starch indicator. So these solutions are present in conical flask. Indicator used. Which indicator is used here? Starch indicators. Endpoints, that is blue to colorless. Endpoint is blue to colorless is required after titrations. Now tabular columns. So how to make the tables? See, this is the format of tables. Serial number, second column samples, third column is description of sample, and fourth column is burette reading in mLs. So that is initial reading, final reading and difference. So here you repeat three trials with sample, each trial 200 ml disinfected water you take. So like sample 1, sample 2, sample 3. So then you note down the readings. So then now you do the calculations after getting the 3 trials. Residual chlorine in milligram per liter is given by the formula normality of titrant into MBR into equivalent weight of chlorine into 1000 divided by ml of sample titrate. In this formula you write the value. Normality of titrant means 1 by 40 into MBR obtained from the table. Equivalent weight of chlorine is 35.45 into 1000 divided by ml of sample titrates, that is 200 ml. So now we are getting the results from the formula. Residual chlorine of the given sample of wastewater is this much milligram per liter. So based on the results, now you write the comments. I have written here one comment of that's based on the results sample. Okay, the amount of residual chlorine in given sample is found to be this much milligram per liter. As per IS specification, the permissible amount of residual chlorine in drinking water must be between 0.1 to 0.2 milligram per liter. Hence, the given sample is highly chlorinated and needs to be dechlorinated to the limit before supply to publics. So this I have written the comments based on the results. I think our result is more than 0.2 milligram per liter. So comment is like that is required. Okay. These are the references are referred for this experiment conduct and study in details of this subject. So these references are referred. Thank you one and all. Next experiment I will be continue in next class.